Welcome to Study Loop.
For this problem, we're told that the density of C7H8 is 0.867 grams per milliliter. The density of C4H4S is 1.065 grams per milliliter, and we're making a solution that involves dissolving 8.10 grams of the C4H4S in 250 milliliters of C7H8. The first thing we're being asked to figure out is to calculate the mole fraction of the C4H4S in the solution. So to do this, the first thing we want to do is we need to figure out what is the mass of how many grams of the C7H8 we have. So we're going to start off by taking the density of C7H8, which is going to be the mass divided by the volume, in order to figure out the mass. So we have the density of C7H8, which is 0.867, equals our mass divided by 250 milliliters. And so we get that equals 216.75 grams. So the next thing we're going to want to do is find our molar masses for both of these substances. So for our molar mass of C7H8 is going to be 7 times 12.01 plus 8 times 1.008, which gives us a total molar mass of 92.134 grams per mole. And then our molar mass of C4H4S is going to be 4 times 12.01 plus 4 times 1.008 plus sulfur, which is 32.065, and we get that equals a total of 84.137 grams per mole. Okay, so those numbers are going to be valuable in just a second. Okay. So we are trying to find our molar fraction. We know that there are 216.75 grams in that 250 milliliters. So now we can figure out how many moles we have. So if we do the moles of C7H8 is going to equal 216.75 divided by our molar mass, which is 92.134, we get that there are 2.35 moles of C7H8 in this mixture. And we can do the same thing for our C4H4S. So the number of moles of C4H4S is going to equal 8.10 grams, because that's what we're told we had, times divided by that molar mass, which is 84.137, which gives us a total of 0.096 moles of C4H4S. So our the total number of moles that we have is going to be 2.446 moles of solution, or in the total solution. So to find our molar ratio for this in the solution, we're going to actually go ahead and divide our 0.096 by our 2.446, which gives us a mole ratio of 0.039. All right, now part B asks us to figure out the molality of our C4H4S. So in this case, we need to take this value here, which is our mass, and we need to convert it into kilograms. So 216.75 grams equals 0.21675 kilograms. And so we're going to take our moles divided by our mass in kilograms, and that will give us our molality. So the molality of C4H4S is going to be 0.096 divided by 0.21675, which equals 0.443 moles per kilogram. And then lastly, part C is saying, assuming that the volumes of the solute and solvent are additive, what is the molarity of the final solution? So we are going to assume that they're additive, meaning we know we have a volume of 250 milliliters of the C7H8. And now we need to figure out how many milliliters of C4H4S has been added to it. So for this, we're going to again look at our density. So we have density is mass divided by volume. So if we want to rearrange that, so volume of C4H4S is going to be the mass divided by the density. So we're going to have 8.10 divided by the density, which is 1.065, which gives us 76 milliliters. Now, to do molarity, you have to do it in liters. So this is going to be equal to 0.250 liters, and this is going to be equal to 0.076 liters. So we have a total of 0.2576 liters. And to find our molarity, we're going to take the moles that we have, which is 0.096 moles, divided by our 0.2576 liters, and that gives us a molarity of 0.373.